Hey everyone, this is Tanmay, and today we are going to talk about a linked list. So before we begin with the linked list, I just want to address this thing. So a lot of like new CS students, they really get worried when they hear about a linked list. They think it's very complicated, but it really isn't, right? So before we begin, just wanted to tell you that it's not really calculus. Don't like try to overcomplicate it. It's simple, just that you need to have some intuitive understanding, right? So today we're not going to really do any programming, but give you a conceptual understanding of what a linked list is. Okay. So before we begin talking about a linked list, you might wonder like, what are they good for? Like we already know so many data structures, arrays, dictionaries, and sets and yada, yada, yada. So why do we need a linked list in the first place? So here's the thing, okay? Linked list store element, but they store them in a different way. And they store them in a way which makes their insertion and removal way less CPU intensive as compared to arrays, okay? So if you know about bigger complexity, you will understand this. So insertion and removal of elements in a linked list is just O of one, that's constant time, as compared to linear time in arrays. On the other hand, if you want to like directly access elements, arrays are way better for that. So, directly accessing elements is constant time in array while it's linear time in a linked list. So depending upon the kind of job you're doing, you'll have to decide whether you want to use a linked list or whether you want to use an array. Okay. So this is what a linked list looks like. And I know like in the beginning, it's just a huge load of information and you're going to be worried, but let's start with the basics. Okay, so I'm going to start with this basic circle out here, and just for once ignore everything else. Okay, just look at this basic circle. Okay, so this circle is basically that box that will store a value for you. Okay, and we call this circle a node. Okay, so this node will store a value and it will have a pointer to the next value, which is some very often called just next. Okay, so remember this terminology. We have a node and it's pointing to the next node using the next pointer. Okay. Over here, we are using these fancy arrows to, convey that they are the next pointers. Now you can see that once you reach this next pointer, there's no way to come back over here. I mean, there's another type of linked list called doubly linked list, but here we are discussing about singly linked list. So over here, there's no way to come back. Okay. Okay, apart from that, we have these other pointers called start and cur. So very commonly, whenever you use a linked list, you have like a start pointer, which basically, points to the first element in your linked list. And then there's a cur pointer. So cur pointer basically, is for doing any task in a linked list, like adding an element, removing an element, searching through a linked list. Okay. And the reason behind that is that if you don't have the star pointer and if you only have the cur pointer and you say reach the third element, and if you don't have the start pointer, the garbage collector in Python will just remove the start pointer because there's no way to come back to it. And we will, talk about garbage collector more very soon. So if it looks a bit confusing, I hope like, once we come back to it further, you'll be able to understand it better. Also, I'm putting up some pseudo code here if you want to try out on your own. Remember that we need to create a node class for a linked list, and the node class needs to have like a value and a next pointer. Okay. So first of all, we'll see the basic operation in a linked list called insertion. So when we do an insertion, say I want to add this element over here, right after the second element. So first of all, before doing that, what I'll do is I'll have to reach this second element in order to do the insertion, right? So I'll write the code something that looks something like this. Okay. While we do not reach the n minus one element, that is the element a position before the element, the position you need to place the linked list at. Okay. Till I don't reach that, till then just take my curve pointer to the next element. Okay. Now, once I reach the n minus one element, what I'll have to do is I'll say the next element of mine would be the new node, right? And then I'll take my curve pointer to the new node. And then I'll tell my computer that the next element to the curve pointer will be the old next of this one. Okay, so this one, the one which we change the pointer to the second element. So the next of the second element will now basically be the next of the new node. Okay. And on doing so, you can see how simply we added an element to the linked list. Okay. So this is insertion, and then we have deletion. So deletion is very similar to insertion. You just need to mess up a bit with the pointers and you should be good. Okay. So how we do deletion is basically like this. So imagine that we need to remove the third node. Okay. So we'll say that while we do not reach the node before the one to be deleted, in this case, while we do not reach the second node, keep going on to the next node. Okay. Once we reach the node before the one to be deleted, all we have to do is that the next of that node, the next of this particular node will become the next of this particular node. Okay. So next of the second node will actually become the next of the third node. And how do you do that? You just say next of cur is the next of cur. Okay. Uh, it's going to be very similar in Python, as I'll demonstrate very soon. Okay, now you might be wondering that do we have to physically remove this node? And the answer is no. So Python has this garbage collector, which basically checks that if there's an object and if there's a way to reach to that object, okay? And for example, in this node, the node which has the red delete this written inside it, if that node does not have any way to reach out to it, the garbage collector will, automatically remove it. And we can see that there's no way to reach this red node now. If we try, we start with the first node, we go to the second node, we cannot go back from here. And then we try going ahead, but then we reach this node. Okay, we are not able to reach this node by whatever means. And voila, here's your new final linked list. So I know this might look a bit complicated still, and I hope like when I do the coding part, you'll be able to understand how it works.